So here we are discussing about the uh, encoders. Okay, so we are focusing our discussions on the optical rotary type encoders. There are different type of encoders. So even there are different type of encoders, but they basically fall into two main sensing technique, that is linear and rotary encoders. The linear encoders can use a transducer to measure the distance between the 2 points, whereas the rotary encoders collects data and provides feedback based on the rotation of the object. Okay, so what is an encoder? That is the first thing you need to know. It's a device that provides a digital output as a result of the linear or angular displacement. So that is the reason why it is used for the measurement of linear or angular displacement. Okay, and once this digital output is produced, it will send back to the processor and will do the needful. Here, the position encoders so are can be grouped into two categories. One is an incremental encoder, which detect change in rotation from some datum position, and the absolute encoders, which give the actual angular position. Okay, and this optical rotary encoders. Now I told you why we are using optical encoders, because the optical encoders are widely used encoder motion translating technology. Okay, the encoders get rotated, and through this we are translating, um, and we are getting the output. So they are also known as the optical rotary encoders are also known as shaft encoders, and they are mainly classified into two, that is absolute rotary encoders and incremental rotary encoders. That is the optical rotary encoders are classified into absolute rotary encoder and incremental rotary encoder. So one, that absolute rotary encoder is used for detecting the angular position or the absolute position or the unique position, whereas the incremental rotary encoder, which detect change in rotation from some datum position or reference position. Okay, that is generally its applications include distance, speed, linear position, etc. Now, in the case of a incremental encoder, both incremental encoder and absolute encoders are used for the measurement of angular displacement. It can be used for the measurement of angular displacement. However, let's see how does it. As I told you, one is detect the change in rotation from reference position, and absolute encoders which give actual angular position or absolute angular position or unique angular position. Maybe one way we can say that is more accurate compared with the incremental, maybe in one way. Now in the case of incremental encoders, here how does it works is, here a beam of light passes through the slots in the disk and is detected by a suitable light sensor. So when the disk is rotated, a pulsed output is produced by the sensor, with number of pulses being proportional to the angle through which the disk rotates. Okay, so when the disk is rotated, the pulsed output is produced by, you will get a pulsed output, and that is proportional to the angle through which the disk rotates. So thus the angular position of the disk and hence the shaft rotating it can be determined by the number of pulses produced, because number of pulses is proportional to the angle through which the disk rotates. അതുകൊണ്ട് തന്നെ you can determine the angular position of the disk from the number of pulses produced from the reference position. Now in the case of incremental encoders, in practice, three concentric tracks with three sensors are used: inner track, middle track, and outer track. The inner track has just one hole. You can see in the schematic diagram. So this the inner track has just one hole and is used to locate the home position of the disk. The other two tracks have series of equally spaced holes that go completely around the disk, but holes with, I mean the holes in the middle track offset from the holes in the outer track by one half the width of the hole. I mean half of the width of the hole. And what is the why we are providing this offset? This offset enables the direction of rotation to be determined. ഏത് ഡയറക്ഷനിലേക്കാണ് ഇത് കറങ്ങുന്നത്? In clockwise direction, the you know that the pulses produced in the outer track, I mean the direction in the clockwise direction, the pulses in the outer track lead those in the inner, and in the anti-clockwise direction they lag. Okay, so you can determine the resolution of this encoder. How? By the number of slots in the disk. If you have 60 slots occurring in one revolution, then since one revolution is a rotation of 360 degree, the resolution is, you can calculate it as 360 by 60, that is 6 degree. 660 is a one revolution divided by number of slots on the disk is 60, so you can calculate, for example. Okay, this is how an incremental encoder works. And in the case of absolute encoder, so this is a basic form of an absolute encoder for the measurement of angular displacement. So it gives an output in the form of a binary number of several digits, and each binary number representing a particular angular position. The rotating disk has three concentric circles of slots and three sensors. You can see at the left side view. Okay, three sensors to detect the light pulses, and the slots are arranged in such a way that the sequential output from the sensors is a number in the binary code. And if you take some typical encoders, they tend to have up to 10 to 12 tracks. Now you may please note that the number of bits in the binary number will be equal to the number of tracks. Thus with 10 tracks there will be 10 bits, and so the number of positions that can be detected is 2 raised to 10. So 1024 actual angular position can be detected using a 10 track absolute encoder. Okay, so what will be the resolution here? 360 by 1024, so 0.35. And again I would like to tell you that the normal form of binary code, the normal binary code is generally not used with absolute encoders, because Changing from one binary number to the next can result in more than one bit changing, and if through some misalignment one of the bit changes fractionally before the others, then an immediate binary number is momentarily indicated. So it can lead to false counting. So to overcome this, a gray code is generally used. With this code, only one bit changes in moving from one number to the next. Okay, I hope you understand. Thank you.